Good morning, everybody. Good afternoon, good evening, and good night for some of you. We've got about an hour, and we're going to have a bit of a deep dive into Zowe specifically for DevOps. For four of us here today, myself, Joe Winchester from IBM, Bill Pereira, part of Zowe Onboarder Squad, works in Brazil from IBM, Mark Collins, a colleague of mine in the UK and Hursley, and from Israel we have Ismail Pazniak from EPAM Systems. So before we get going, one of the things I'd like to three taglines about Zowe, I think. Zowe's got great tech, and you'll see that today. A lot of the tech that's in Zowe today wasn't there at the start, and some of it wasn't even there a few months ago, and the tech will change in a few months' time. So the most important thing in Zowe, and the thing that most open source communities live or die by, is the community. The community around Zowe is the strongest thing we have. And for everybody out there who's in the Zowe community, thank you from me for being involved with Zowe to date. And please, if you want to get involved in open source, it's a great community. Jump in, you'll find it very welcoming, smart subject matter experts. Zowe, when we first worked on designing Zowe, I was fortunate to be there on day one when all Linux Foundation, people from CA, now Broadcom, Rocket and IBM got together and did some design thinking, and those three words were written on the flip chart: open, simple, familiar. Open, open source, open governance, open, etc., etc. Simple, we want Zowe to be simple to operate, simple to extend, simple to use, simple to understand, and familiar to people who don't know the mainframe, are coming at it from a distributed background, perhaps newly out of college, have never been near a mainframe, but very powerful with other tools and other non-mainframe languages. We also want the Zowe to be familiar with people who are familiar with JCL and Rex and are Power TSO users. So you have to bridge both communities. That's very important. And for that, we have another tagline called all of the old with all of the new. Even though we adopt lots of new technologies in Zowe, we try and embrace all of the old stuff and move that forward as well. Very, very important for our success. Linux Foundation owns Zowe. IBM, who I work for, is a major participant in Zowe, as is Broadcom, Rocket, Phoenix Software, Sega Software, and others. But the Linux Foundation is steward, and the most interesting thing in Linux Foundation, if you've got the projects that they take care of, Jenkins, Helm, Kubernetes, Open API, Cloud Native Computing, and Zowe itself, the Linux Foundation, the philosophy behind the Linux Foundation. They have a bizarre model. Linus Torvald basically said, code developed over the internet in view of the public. All development of the code, all governance of the code, decision processes. And the other thing I love from Linux Foundation is the next best thing to having good ideas is recognizing good ideas from the These users, Linux Foundation's success of its projects is not the technology being driven top down by organizations. It is users and a community around that driving it forward. So Zowe itself, from the outside in, has four major components. It has a command-line interface, the Zowe Explorer, which is a Visual Studio Code plugin. It has an API mediation layer, which is based upon Netflix Zowe, which can run on ZOS and provide lots of capabilities around APIs, and it also can provide things like multi-factor authentication, single sign-on, and workload management for these, which are running particularly on clients, and we also have the Zowe desktop as well. All four of these are extensible. So the first component of Zowe we're going to look at is the command line interface, also known as the CLI. The CLI runs anywhere that Node is installed. It has a client-server relationship to ZOS, and it allows me to interact with a textual interface. So here it is in a Bash shell on my Mac. I also have other CLIs. I have one for Git and I have one for Docker. So it fills that sweet spot where you can just type commands and orchestrate and manipulate a server machine using a sort of natural language interface. The CLI itself talks directly down to ZOSMF in its default configuration and encapsulates all the REST APIs, does heavy lifting, orchestrates various REST APIs together, and surfaces those up to a client machine. By default, it comes with the groups, which let you work with jobs, files, TSO, or workflows. It also has some extensions as well. We'll look at those a little bit later. Now, what's interesting is if I don't know what to do with the CLI, I can type Zowe files, which is one of the groups, and it tells me everything I can do. I can copy files, create, download, give me all of the help. Now, if I just decide, well, actually what I want to do is list data sets, list, or ls is a short one, and I can see those. The next command I'm going to type is Zowe files list. And Zowe files list will show me, what do you want? Dataset members, Unix file system. I can say, well, actually, I want Zowe files list data-set, or DS for the short name, and then I can type Zowe files list ds help. So what's interesting here is the more information I'm typing, the more it's just revealing what I need to know to get my job done. And over here it's telling me, well, actually there's various, I can get list attributes, I can throttle it, or I just want to get data sets for a particular high-level qualifier, which I've gone and got now, which is my user ID, ZWE. So often people say, well, that's great, but I could have SSH'd into my mainframe and done that. You could have, but I'm running this on my Mac. So because it's on my Mac, I can say, I can start grepping it, I can get the results, I can format it as JSON text, and you've basically got this powerful client-server relationship. If you don't know the commands as you want to punch in and narrow down, a neat feature of the Zowe CLI has got Zowe Help HW. It'll list in a little web application all of the commands available, and you could type and search, and you can see the help that's available. This is extensible as well. So a good open source framework has to have stuff in the base, like a mobile phone's got base applications, but also be extensible. So on npmjs.com, which is where you can install the Zowe CLI from, you can go and look at Zowe CLI as one of its packages, but there are many other packages available that come from vendors. So Zowe S Connect is an IBM product, so Broadcom have got one, I think Phoenix Software have got one for EJS. So it's extensible framework, and that's really neat. So when I type Zowe MQ, for example, and I can see Zowe MQ, having installed Zowe, I can just type Zowe plugins install, point to that namespace, and then start running commands. I can run mqscc commands. If I want to talk to DB2, I can say Zowe plugins install DB2, and then I can start running store procedures, execute SQL with SQL strings, export tables, Zowe CICS. We'll see a bit more of this from Mark later. Zowe CICS define programs. So you're building up different extensions and different plugins for base Zowe. It's not just talking to ZOS-MF, it can talk to other ZOS servers as well. And as you install the plugins, the help that I showed earlier that showed me how to submit a job gets richer. So now I've got CICS, I can say, oh, what can I do with CICS? And it will tell me, oh, I can get resource, and it's got copies of resources. So this is a very extensible, powerful framework where it doesn't just give you operation for extensions, but it gives you the help and the content assistant for operations as well. Now, I showed some of the extensions earlier and how you could get them from npmjs.com. How do they actually, how do they work, and how does each extension itself is its own set of node packages and will talk to its back end. So you end up with a client-server configuration where they can share the sort of TSO user ID and password, but independently they have to be configured to talk to IMS Connect or perhaps DB2 or an MQ console. So that has advantages, because if these are available on DOS, you just install it on your client machine. But there are disadvantages, because you have a one-to-one relationship. You have to know each endpoint, and it doesn't necessarily scale particularly well. And the other disadvantage it has is that the TSO password is thrown on each REST request for this one and for that one and this one. So the persistent passwords are vulnerable to theft and impersonation, perhaps by phishing attacks or just by being careless. So Zowe also has a ZOS component. You'll see more of that later, but the API mediation there with support of Netflix tool, if it's installed, provides a slightly different connectivity model where your CLI just connects with a one-time use password that can be multi-factor authentication. Then it generates a token, and you're actually able to talk to the ZOS backend through either pass tickets or the token itself. And it can also handle a one-to-many relationship with workload management. So that the CLI talks directly here, it can talk to multiple copies and find the most available copy of a backend. It's also available so that you can have one certificate here and only one port, and you don't need to know the location of these ports or even be exposed to the certificate that might be a local. Great. So the next component of Zowe we're going to look at is the Zowe Explorer. The Zowe Explorer is a VS Code plugin. VS Code is currently the sort of #1 IDE, very popular. People learning it in college. It's very, very good for some of the sort of modern languages. Very extensible, really rich marketplace of plugins. Conceptually, the Zowe core CLI is written in Node and handles things like connectivity, profiles. It's able to talk to ZOS-MF. Through extensibility, it can talk to other subsystems. It's able to go through the mediation layer and do sort of token-based and multi-factor authenticating. So TypeScript, which is compiled Node, is effectively architecturally sits on top of the CLI. It's another way of sharing the same heavy lifting that the CLI does. And by default, it can talk down to ZOS-MF. Okay, the next component of Zowe we're going to look at is a very popular VS Code plugin called the Zowe Explorer. So VS Code is written in TypeScript. The CLI, as we saw, provides a lot of powerful heavy lifting to talk to ZOS-MF. It can do token-based authentication. It's extensible. TypeScript is compiled Node, so it shares a lot of the same logic, but rather than having a textual interface to drive the mainframe, we're driving it through a VS Code extension. but conceptually it looks a little bit like this architecturally. If you have VS Code, you click this little sort of doohickey down here and type the word Zowe, and you'll see the Zowe Explorer. It's currently got 20,000 downloads. Back in, today's November the 3rd, back in March the 3rd, it hadn't even passed 3,000 downloads, so it's really flying off the shelves. People who are familiar with VS Code are normally familiar with working with local files on their file system. Perhaps have checked out Git. These are going through the ZOSMF connection. These are data sets, PDSEs, members, Unix file system, and jobs. So equivalent of the ISPF 3.4, 3.17, and S2.7 if you're familiar with those traditional interfaces. Now the Zowe Explorer out of the box provides the ability to edit files, create them and upload them and so forth. But it doesn't provide any editors. This particular editor came somewhere else out of the VS Code marketplace. So sometimes people ask questions, can the Zowe Explorer work with assembler, JCL, Rex? The answer is yes, yes, yes. It will let you edit them. But depending on how you want to syntax color and highlight them, you can go to the marketplace and get other plugins for that. And you have that really nice fusion going forward. So I'd encourage people to do that. And you can get plugins for working with Java and Node and debugging and so forth. You can do filtering of your PDSs based on your high-level qualifier. And you can connect to multiple backends. These are basically CLI profiles, dataset members, submit jobs. Once you submit a job, you can download the job files. And what's really nice about this, and why I prefer this to STSF, is I don't have to PFK 8 and PF7 and 11 and 12. It's a very nice productivity tool. You can just control up, control down. You can search within here. You can see the little thumbnail. Very powerful tool. And with Unix files, you can edit and create files, and you can also upload, which is very nice. So you're uploading across that back end, which is benefiting as well from multi-factor authentication, so you don't have to SFTP or SSH your way in. Okay, to really get a feel for what you can do with VS Code and the Zowe Explorer, super pleased. We've got Bill Pereira next. Bill Pereira is part of the Zowe Onboarding Squad. For those who don't know him, check him out on social media. Check him out on YouTube. He has his own playlist all about Zowe. And now we're going to hear from Bill himself.
So, the Zowe CLI. This is something I really enjoy. As you're going to be typing, it will be helping you to remember what you want. So, for example, if I go a bit further, it changed the help. I can see here now the help for the Zowe files. So I can copy, create, list, download. There are numerous options. So let's list the datasets that start with my prefix, so my user ID, and GSE. We're gonna see a list of all datasets that is starting with this. So if I clear, let's create a new dataset. And I don't need to worry about the attributes because it has some defaults. You can obviously override that, but for now we're gonna go with the default. And we can play with that, even without go direct to a session there. So let's create a demo JCL here. So it's a file. I will just create our demo GSE job and add a step here. IFBR14. So just a hello world of JCL. When I save this file, it's on my machine, and I can then play with this direct from my machine, from my terminal, or I can upload that. So let's just verify if it has been saved, and it's here. So we are ready to upload. So let's use Zowe files upload file to dataset. So we can point our demo.jcl that we have just created here, and then use the dataset that we have created previously with the Zowe command. When the file is being uploaded, we receive this feedback. So if it has been uploaded with success or not, and what is the file that was uploaded to where. So now, for example, we can use Zowe job submit, and let's see the options. So on the jobs, we can use a local file, so we can submit that even without uploading, but we are going to use now the dataset. So let's clear the screen and let's use the Zowe job submit. dataset option and pass the file that we have created on our mainframe on our ZOS. I will use here the flag wait for output. So I want to wait the job completion so I can verify the return code of that. So as you can see, that was completed with 0. There are other options that we can use and play here. For example, you can return the answer in a JSON format so it's easier to use in your coding. Or for example, let's use here the VASC to return the content so we can check how this job run inside our terminal. So right after I submit that, I see here the results. So now let's edit demo.rex and create our hello world here. So it would just display this message, and through the CLI we can not just handle files, submit jobs, but we can execute TSO commands. So let's upload this to our demo data set. So we can then execute this as a TSO address, so we can execute the TSO command there to run this Rex. So using the TSO issue command, let's use execute and pass here the GSE dataset we are using for the demo. Perfect. So now we see here the hello message. Other option that's very useful for me is the ability to send Unix commands from the Zowe CLI also. So I can use the USS option to issue an SSH and issue a command to my LPAR. So for example, ls even al, and these the files. You can use that to run scripts, all kind of commands that you would be needing an SSH connection. You can have your profile and issue this automatically from the Zowe CLI. And just to confirm that we are on our system here, I will use this display file system for us to see that the directory where I am, it's mounted on a dataset on ZFS. Through the console option, you can issue MVS commands to your system and get the answer direct on your terminal. So as you are getting this answer, you can also use, for example, you can pipe that to a grep and get just information you want to see. For example, now the device is here. So now let's go to the VS Code. On VS Code, we have also another part of Zowe project, that's the Zowe Explorer. And that's something really cool. So here is my current directory. But if you go to your marketplace here, you look for Zowe, you're gonna find the Zowe Explorer, and you will be able to install that also. As you can see, there are a lot of other extensions using Zowe right now. So when you have the Zowe installed, you have these 3 sessions here in the right panel, and you can have multiple LPARs, multiple profiles, and you can handle datasets, USS, jobs. So let's add here the filter we want to use, and that will bring all datasets starting with this prefix. Now we should have 2. So the GSE demo, where were uploading our files we just created here. And here you can use high-level highlighting for your coding for JCL, COBOL, assembler, and this is really helpful sometimes. We have here also an RPDS where I have a JCL library that's gonna be being updated here automatically, synchronized with GitHub. Next steps. So here I have my current directory where we have the files we just played a bit, and we want to keep this dataset. So we can upload members just clicking here with the right click and finding the file we want just to upload. So for example, let me just search here the demo JCL. I select it and I just click upload, and then our file is here. So very simple to upload files from our machine to our helper. We can then just submit this job using right click, and we see the answers. We can relink it to them. Let me refresh, and there we go. So here's the results of this execution. You can then navigate through that. Okay, but let's imagine a scenario where we have our JCLs, these libraries, on just one place, and we can just synchronize everything. So, for example, keep multiple pars just synchronized and our library being updated automatically. So let's create another member, another file inside of this folder. So when we create something on our machine or on our any place, that will be automatic. So let's use here some snippets just to get something created. This is really cool. This comes with IBM Z Open Editor. You have here our demo GSE step. Okay, just a file just as an example. Oh, I have a typo here. Well, we are not submitting this. So let's just see here. We have also in this directory this file. This is for GitHub Actions. And what happens here? So all these steps, they will be executed when I just have an update on my branch, so on my main branch. So this workflow, it has the jobs, the build, it will be running on Ubuntu with Node, and when it starts, it's just check out to get everything I need from the repository. We'll set up the Node.js. So remember, Zowe CLI is a Node.js application. So I'm setting this up here. I will issue a message that I'm starting. I use some secrets here to have the ZOSMF port, user, and password. And I just issue the commands like I would be issuing on my terminal. So I check the node, install the Zowe CLI, check the Zowe is installed correctly, create the ZOSMF profile that I will be using, and then I show a message, list the files from this folder, and I upload all the files from this directory to my PDS. So I will save. Let me open my terminal here, and as I said, when I add this, so let's see here, we have the Git status. So as I will be committing this file to my repository, this is gonna be forwarded to my PDS. So let me add this. Let me add the commit, and let me push this. So now, when this push finishes, this new file FBR14 that was not on the PDS will be there. So let's take a look on Chrome to see the job, the actions run fine. So let me go to my GitHub, github.com/Pereira, and let me see here what's the repository. So repositories. So this is Zowe SDK, so it's public. If someone would like to take a look here later, just access there. And I have here this running. So this build is running. The demo already started and everything was completed right now. So we see here that the profile was created, the secrets are there, and we see the files being uploaded. So it listed all the files that we have and uploaded all of them to our members. So any update on any member, and it's reflecting on my library on the JCL. So if I go back to the Zowe Explorer, I refresh the folder, and I see now that I have VR14 here. It was a basic overview about what's possible using the core functions of the Zowe CLI, but that can be extended with plugins, so you can have plugins for multiple other products. So take a look now on a demo if you were, for example, handling something with CICS.
Okay, thanks, Bill. Now we're in demo mode. This is great. And it's all becoming very real, I hope, for you to see the Zowe CLI, see the Zowe Explorer. Let's look at what Mark Collins has got working for CICS and a very CICS-specific scenario using the Zowe Explorer. Over to you, Mark.
In this demo, I will demonstrate how you can use some of the tools provided by the Zowe project to enrich the developer experience when developing applications for CICS Transaction Server for ZOS. Before we delve into what the Zowe tools can provide, let's briefly remind ourselves of some of the previous interfaces that have been used for developing CICS applications. ISPF has been used for many years for interacting with the mainframe, including application development. ISPF is still in use today, and over the years, additional interfaces have been provided. Examples of these are the IBM Explorer for ZOS, the IBM CICS Explorer, as well as tools like the IBM Developer for ZOS. All of these Eclipse-based tools have helped with aspects from editing datasets, members, and files, including application source code, through to submitting jobs and interacting with CICS resources. Now, with Zowe, we take the development experience to include a modern CLI, as well as extending Visual Studio Code, one of the most popular IDEs around today. In this demo, I have a very simple CICS COBOL application that I want to make a change to. This application is made up of two programs. The first handles the interaction with the user, and the second gets the account information for the account entered. Here is this application in action. Here we have a connection to a CICS terminal. If we invoke the ACCT transaction, passing in an account number, we can see that the account information is returned and the balance is £100. We are now going to use the Zowe Explorer as well as the Zowe CLI and CICS plugin for the Zowe CLI to make a change to one of our programs. Here is the Zowe Explorer. I already have a profile with a connection to ZOS using ZOSMF. I'm going to open the member that has the COBOL source for my second program. When I open this member, you may notice the syntax highlighting. This is not actually provided by Zowe or Zowe Explorer, but by the IBM Z Open Editor, another extension that you can download from the Visual Studio Code Marketplace. This extension provides syntax highlighting, as well as some other features for developers, for example jumping to the variable declaration and viewing all the references for a variable. This shows how Zowe Explorer, as well as other extensions, can come together to provide a rich developer experience. I will now change my source code so that the returned value is 200. Once I have saved this source, I can go to the JCL to compile my program. Using Zowe Explorer, I can submit this job, and once submitted, I can click on the link and view the output for my job to check that the job has completed successfully. We now need to perform a new copy of our CICS program to reload the new version we've just built. To do this, we can use the CICS plugin for the Zowe CLI. Here, in the terminal window in VS Code, I once again already have a profile with a connection defined to CICS. Using the CLI, I can check the new copy count for my program, in this case 11, and then I can issue the refresh command to perform the new copy action. Once I've done this, I can once again check that the new copy was successful by checking the new copy count. Now we can go back to the CICS terminal and invoke our transaction again. And you can see that the value has now been updated to 200. The last aspect I'm going to demo is how you can use Zowe to further enrich this development experience by integrating with source code management and an automated build pipeline. If I now switch to the Explorer tile in VS Code, here you can see the local resources I have on my laptop. The source code here is identical to what I was editing on ZOS, but this time this source is located within a Git repository that I have cloned to my laptop. Once again, I will make the same change. This time we will change the balance to 500. Now, to compile a new copy in CICS, I will commit and push my code to GitHub. Once in GitHub, these changes will be picked up by my build automation pipeline, in this case, Travis. Now that these changes have been automatically picked up by Travis, Travis will run the build pipeline to build the new version of our source and deploy to ZOS, completing the new copy action. While this is building, let's have a look how this is defined in our Git repository. In this travels.yaml file, you can see we used several aspects of the Zowe CLI, from creating profiles, through to using the SSH functionality to create directories, using files to upload our COBOL source code, using the jobs function to submit our JCL, and finally, using the CICS plugin to perform our new copy action. If we now check back in Travis, we can see the build was successful, and we can run our transaction in CICS again to see that the value has been updated. This video has shown how you can use Zowe Explorer, Zowe CLI, along with the plugin for CICS and VS Code to enrich and modernize the CICS developer experience and start to build automated CI/CD pipelines using technologies such as Git and Travis.
Awesome, thanks Mark. So that really showed how the Zowe Explorer connecting to sort of base ZOS through ZOSMF or perhaps an ROC backend is able to sort of work with jobs and PDSs, members containing COBOL files, and basically work with CICS. But Mark was still dropping down to the command line interface to do things like the sort of new copy and stuff like that, and also the terminal emulator. So hot off the press, there was a sort of hackathon just within IBM. It actually just finished last week. So on November the 2nd, I'm adding into this recording a little update from Mark about the team there challenged themselves with, could they make it so that rather than having to drop from the Zowe Explorer to the CLI, that you still remain within the Zowe Explorer. It can become a more of a VS Code immersive experience. So let's see what Mark and his team came up with.
Here is Zowe Explorer in Visual Studio Code. Using this interface, a developer can open a program, as I have done here, and make changes to their program. They can then switch to JCL and submit the JCL to compile their program, all within Zowe Explorer. Now, once the developer has built their program, they can move to the new CICS view contributed by our VS Code extension in the bottom left corner of Zowe Explorer. The first time they use this, they will need to set up a new session like this. Once the session has been created, the list of CICS programs will be displayed. To reload their program, a developer can find it in the program list, right-click and new copy, completing their development flow. We have also added support for more complex multi-region CICS plexes. For example, you can now add another session and see we are now connected to a CICS plex with multiple contexts or regions and a different list of programs.
Awesome, Mark. Thanks so much for showing that. And as I said again, that's very recent, so kind of hot off the press. If anybody wants to get involved with that, please reach out to the Zowe Explorer squad. You're going to see a bit more of that in the open coming up soon. Join the Slack channels. Get involved if you're a customer, want to have some early drops of that. If you want to contribute, configure it, give ideas about the user interface, the workflow, so on and so forth. You can see a lot of great improvements in line for that. But coming back to sort of Linus Torvalds' quote right at the start, we don't want to be technology driven, we want to be community driven, and the best ideas really do come from our customers. Okay, so before we go back into some of the great demos that we're now hitting us right about, a couple of things I want to give a little bit of background about. So Master the Mainframe is a contest that in 2019 was 15 years old, and it really began teaching students how to, faculty teaching mainframe skills. Students can enter and get prizes. Actually, anybody else can enter, not just students, but everybody else doesn't get prizes, but you can still get sort of a claim accreditation if you complete it, and it's split into different modules. So for the first 15 years, it was taught using 3270 emulators, and it was taught using ISPF and SSF and so on and so forth. So people coming out of college, joining companies, sort of knew the mainframe based upon its traditional interfaces. I love one of my favorite pictures that came off of sort of Googling, finding out about this is a couple of kids, sort of university students, pointing at a screen, and you can have a caption contest about what's really going through their mind when they're pointing at a sort of ISPF 3.4 member list. But there's something slightly ironic about teaching mainframes to the next generation using technology that's not the latest technology. It's not the most modern technology, even though it's incredibly powerful. So the Master Mainframe team challenged themselves, and within 2020, when it was launched, I think on September the 15th, it's actually taught using the Zowe Explorer and some other VS Code extensions as well that teaches Ansible and things. That's absolutely phenomenal. And that's one of the reasons why the downloads have just gone through the roof now, and they're now sort of 20,000 plus, because I think 25,000 people actually registered for Master of the Mainframe 2020. So that's a great success story. Bill's going to talk about that a little bit coming up soon. And one more thing I wanted to segue into is SDKs, SDKs Software Developer Kit. If we look at this Zowe diagram that we've been using beforehand, let's look at this top right-hand corner, and let's narrow it a little bit. Remember, I talked about Node. The CLI is written in Node. It's written using, it's got the concept of profiles. It does connectivity. It can deal with multi-factor authentication. It can talk to all the different backends and do the heavy lifting. It evolved as being the CLI coupled with all of its packages. Then it was extended to work with the Zowe Explorer, which is TypeScript. That's great if you want a command line interface. That's great if you want a VS Code interface. What if you just want to program to the Node layer? What if you're just a Node developer wanting to build a Node application running somewhere that Node does for perhaps a Node web page or something like that, a Node server, and you still want to benefit from the frameworks of imperative, from the concept of profiles, and being able to talk to the API mediation layer and have your workload balance. And that's really the beginnings of the Node SDK, and that's something great. It sort of started to form around last year and is really maturing this year. So let's go and have a look. Bill's going to talk a little bit more about the Node SDK.
Hi, it's Bill again. And now I want to talk about a real case, something that was a challenge for us this year, and that Zowe was the key for us to complete that. So you probably heard about Master the Mainframe, right? So this is a global competition where people from all different time zones are getting access to a real mainframe and are completing challenges, getting in touch with a Zowe SLPAR, a real one. And we had a scenario where we had the users, they have their user ID, the password. They constantly forget about the password, and that's something cool because it's a real story. It happened with me last year, and was the first time I had this idea to connect these dots. And so we had two issues. One is handle the user ID and password for all these users in different time zones, and they want to get an access, a way to get their password reset. And also there is they are always looking to know if they have completed or not their challenges, if it's correct or not. So we have the challenges in another cloud platform, another cloud service, and this doesn't have access to our mainframe. At least it didn't in the beginning. So this is where the Zowe SDK came to help. So it provided for us a way to solve this issue with the user ID and password management, and also a way for users to know, for this platform to be connected with the mainframe and see that the challenges were being completed fine. So let's take a look on these two challenges, how we managed that. So the first, the user and the resume and reset of the password. So there isn't specific challenges. So they have an option inside of the platform to set up their machine, their Visual Studio Code, the Zowe Explorer, their profile. And when that happens, this trigger are user management services. So we have a Node.js application running on IBM Cloud, and this is like the controller for everything. So it received this request saying that the challenge is completed. So now they need a user ID and password, and it uses the Zowe SDK to resume their ID, to reset their password, and then update inside of the platform. So this is the piece of code where we are connect this. So this JavaScript word with the mainframe word. So first, this function, it receives an ID and a mail. So this is what we are using, because when we are resuming and assigning an ID, we are marking the email on their HACF data. And so once we have that, we need to find if this user ID has a read or not a mainframe ID and assign that for them, generate a random password, and we go to the Zowe part. So we have a command where we are setting this HACF command. So we are altering this user, so setting their password, informing the email, and then resuming that. So to use the Zowe functions, then we use this ZOSMF session, create basic ZOSMF session to create this session. So it uses the imperative to get all the information that we're gonna need for the connection, and use the command Zowe issue TSO to issue this command. So we have to inform the session, the account, and the command that we are issuing, and we are ready to just inform the system on the cloud that, okay, this is the mainframe ID and their password. So that was really a big issue. And as I said, in the past, one time I forgot my ID. To be honest, I didn't forget the password. I was using the wrong email and the wrong IP for that, and it was very late in the night, so no one would be wake up. So to reset that was the first time when I just decided, okay, we need a better way to to manage that. And the second challenge where we use the Zowe SDK is to keep the system informed in real time that a challenge was completed. So this process is start on the mainframe. So there is a Rex there that we created to call the services, just saying, okay, this challenge is completed. Please validate it, and then all the process to define based on which challenger starts. So to request the data, send the data back, and here is where we use the Zowe. So we use that to get this data and then validate it, and if it was successful, then we mark the completion on the platform. So some examples of the functions that we've just used the Zowe. So here we have a function to get the content of a data set, and here we pass the data set name. And then again, every time we are using the Zowe, we need the session. So we create the session based on the profile, and then we use the zoe.get.dataset to get the content of the dataset. So we pass the session, we pass the dataset name, and we got the data, and we return that data in a string format. Another example of things that we need to validate are the members that are inside of the dataset. So we have this list members functions where we pass the dataset name, and then we use the list all members to get a list of all the dataset, all the members inside of that dataset. And here we return the members in a list format. There are some actions on the competition that are done inside of the USS part. So we have also to be able to get content from the Unix system services. So again, we have a function, a issue USS command defined, where we pass the command that we want to issue inside of this OS. And here it works a bit different, and this is something that we noted in while we were developing this. So we have created this response array because the answers are not coming just in a single time from the system. It's coming like a stream. So we created that, and when we go to the Zowe side of things, so we use the shell execute SSH. We pass our session, we pass the command, and we pass this this function to be executed, populating this response to get the data. So as the data is coming from the ZOS, we are populating the response, and then we are ready. So this is something that was a real example, and we were able to connect these two platforms. There are a lot of other microservices that we been using here for the master the mainframe this year, and the Zowe SDK, it was really the key for integrate the services or the content that we have inside of the ZOS together with all these other cloud platforms we were using, cloud services we were using. Thanks.
Okay, so that's great. So Bill has just shown how the power of, if you're doing client server, beginning with a user interface, which was a CLI, and then splitting off the node layer and providing that to as a development interface is hugely powerful. What about other languages? So one of the really interesting things that came along recently was the Swift SDK. So this is available. It's a Zowe project, github.com/Zowe, Zowe Client Swift SDK. You can read a lot of information about it in the repository. Swift is basically the language to develop sort of Mac OS applications, and there's a phenomenal blog QR code right there written by Ismail Pasniak from EPAM Systems, but you don't have to read the blog. We've got Ismail right here. So Ismail is going to take us through how the Swift SDK for Zowe works.
Hi, I'm Ishmael from EPAM Systems, and the goal of my today's lightning talk is to show you how Zowe Swift Client SDK can help us bring the mainframe to any modern application. The following operating systems are covered in the scope of this presentation: Mac OS, iPad OS, iOS, and Watch OS. Zowe technology can be used to deliver the mainframe on those operating systems natively and in a straight and effective way. We will need the following tools set up: Mac OS 11 Big Sur, Xcode 12, your personal mainframe user ID, which can be obtained in terms of COBOL programming with Visual Studio Code course or Master the Mainframe 2020 contest. We will also see how Zowe Swift Client SDK can take scripting to the next level and make it much easier when dealing with the mainframe from a regular command line interface. Zowe has literally opened the mainframe to the modern world and taught it to speak new programming languages, like Python. In fact, Python has become so crucial to the mainframe that it has evolved into a standalone Python client SDK for Zowe and deserves to be covered in a separate discussion. This year, the mainframe has begun to speak Swift, as Zowe Swift Client SDK has come to help developers bring the mainframe to the mobile devices and applications. Before we see how, let's create a simple mainframe scenario for a very basic command line application, where we will create a partition dataset with default attributes, upload a callable and the JCL source to it correspondingly, submit a job from the JCL source uploaded, retrieve and display its execution results. We would do it like this, in a traditional Zowe CLI way. And we will do it like that, in a new Zowe Swift Client SDK way. It's Xcode time. Let's get down to coding and see how easy it is to make the above steps into an application. We will start with the one that runs in a command prompt to keep it simple for now. Choose Create a new Xcode project, select macOS, command line tool, name it and click Next. Provide the folder and click Create. To attach the Zowe Swift Client SDK, choose File, Swift Packages, Add Package Dependency. Enter the Git repository address and click Next. Choose either the version, or the branch, or the commit to install from. That's it. Our application is now well equipped to work with the mainframe. Now we need to import Zowe SDK to our project, initialize it with the user's credentials and start to pass our Zowe commands to execute on the mainframe. We can assign the callable and the JCL source to the appropriate variables later, or store it somewhere else in our code. We will need a struct to save the job data, returned by the submit a job from the mainframe command and required by the subsequent get spool file contents request. Build our application. Expand the products folder. Right-click the executable and select Show in Finder to locate it. Then drag it to the command prompt to run. See how we send request by request, receive the results, and get all these with very minimal code. Now let's step forward to the real native macOS application. Choose Create a new Xcode project, select macOS and App instead of Command Line Tool. Then simply repeat the same steps as we did before. This is how the application code looks like after all 5 Zowe commands are added and wrapped into the sample Swift UI methods. Pay attention to the entitlements property list file, where we need to add the security network client key to grant our application with the proper network permissions. Beware of the job struct nested into the individual response struct, and mind the callable and the JCL sources moved to the separate class extensions. Build and run our application. Let's see it in action. Works as intended. Next, we will target mobile devices. Starting with an iPad. Choose Create a new Xcode project, select iOS instead of macOS and App. Repeat the steps we performed previously. This is again how our application code looks like, with all 5 Zowe commands added to the Swift UI project sketch. We must select our iPad simulator model to launch on. Then press Play button to build and run. We can see the iPad communicating to the mainframe from the application we have just created. Well done. Change a simulator model from an iPad to an iPhone, then build and run the application for a new model selected. This time it's a smaller device. but it still works as cute as those before it. Have you got inspired? Then let's get to the smallest device ever and make the mainframe interact with an Apple Watch. Choose Create a new Xcode project, select Watch OS and Watch App. There's an important detail to emphasize. When it comes to package target selection, make sure you select Watch Keyed Extension under Add to Target column title. The Swift UI code looks almost the same after all 5 Zowe commands have taken their places. Build and run again. Here is mainframe being communicated and interacted from an Apple Watch. Works like a magic. If you are familiar with the Zowe Explorer extension for Visual Studio Code, which provides us with a modern desktop interface to the mainframe, then this is how our flow would be done from there, using a rich graphical user interface and many interactive menu options. The Zowe Swift Client SDK paves the way for the implementation of the similar graphical user interfaces and interactive menu options in mobile applications. For example, a mobile application might look something like this if we want to build the Zowe Explorer for Visual Studio Code functionality on an iPad. Awesome, isn't it? Think of the opportunities it opens up for us. One of them includes the possibility to convert the native SDK and use it as a NuGet package for cross-platform applications created with Xamarin. Another proposes even a greater potential by going far more cross-platform. The clear directions towards that have come with the latest Swift 5.3 release. This brings us to the end of our today's journey. However, there's no telling how far we can go with Zowe if we turn our imagination on. Because from the command line interface and up to the newest and smallest devices, Zowe has us covered. Thank you so much for watching my tutorial and have an amazing God share Europe. Bye bye.
Thank you so much, Ismail, and thanks for reminding me as well about the Python SDK, which is a great addition to Zowe as well that came along recently. So we've run out of time, got to the end of the session. Thanks everybody who stayed so long. Thanks for the great speakers who co-presented with me. Please, everybody who's interested in Zowe, even if you don't like what you see, but you'd want to change it to something else, please get involved. We have a Slack channel, slack@makeoproject.org, different groups with different squads, lots of subject matter experts, great discussions going on. Please get involved, even if you're on the outline. All of our meetings are published on an open calendar. We're not just open source, we're open governance, so you can join, see what the squads are up to. Some great blogs. We saw Ismail's on medium.com/Zowe about Swift SDK. There's many others about there, not just about core Zowe. There's one here about using CA view alongside Zowe, marked with ecosystem. Lots of great ones about people extending Zowe in the community. Obviously, our source code is on github.com/Zowe. We've got 60 repositories. You can see the source code for everything you can do. You can clone it. You can start to make pull requests and get involved. You can see all of the issues, raise issues. You can even start fixing issues. Get flagged as good first issues. If you want to get a commit about coming up to the end, please give us our feedback. Let us know what we did wrong. Let us know what we can do better next year. 3AC is our session code, and GSE, as it does every year, is a phenomenal not-for-profit group. And please follow the link. And there's a call for charities, and NHS, National Health Service, is doing a great amount to help people through the medically through the current time. So everybody stay safe, and hope to see you all next year when GSE happens. Thanks so much for staying on for this talk, and please enjoy the rest of the conference. And thanks so much to the conference organisers for putting this on again and doing a wonderful job. Cheers.